Richmond is our home and we're ready to learn. We'll find fish, birds, and bugs everywhere we turn. If you're with blue sky, you know we're exploring. So come on, let's go and have some fun.
From the boats traveling down the canal to the tracks traveling along the raised track, there's so many things to see and hear here at Great Shiplock Park in the east end of Richmond in the area known as Shockoe Bottom. Today, we are going to explore two of our most important senses, light and sound, while we're out enjoying this beautiful weather. If you'd like to follow along with us and keep track of everything that we learn and do, please feel free to download our science log found in the description box below. David, what do you already know about light and sound?
I know that our ears allow us to hear sounds and that light can be different colors.
What would you like to learn about light and sound?
I want to know how sound travels through different objects as well as what light is made of.
Well, today we are going to learn about how energy is transferred through different types of matter, like solids, liquids, and gases. Can't wait to explore light and sound with you.
Me either. These tumble setups show how sound travels through solids, liquids, and gases.
Yeah, so when gas molecules come together in a space, they move freely all around. So there's lots of space between them, just like the first row of dominoes.
Okay.
Then liquids, they can move freely and do take the shape of the container that they're in, so they're not as close together, similar to the middle row of dominoes.
Gotcha.
And lastly, when you have a solid, solids are packed close together because they hold their form, just like our last row of dominoes. So when sound moves through a gas, a liquid, or a solid, do you think that it's going to travel faster through a solid, a liquid, or a gas?
My guess would be a solid because, like you said, the atoms are really close together.
They are really close together. So let's knock down these dominoes and see just how fast sound would move through each of them, and if the sound would reach the person on the other end of the solid, the liquid, or the gas first. You ready?
Yeah, we should definitely make them race. Do you think we can do it? Okay.
Let's go. Ready?
Yes.
3, 2, 1, go.
Ooh, that one definitely finished first. That's second, and that one was third.
Yeah, I think you're right. So sound vibrations are definitely going to move more quickly when they have a solid to bounce off of or travel through. Whereas if you're far away from somebody in a wide open space where there's just lots of air, it's going to take a lot longer for that sound to get to you.
Correct.
Let's keep investigating sound.
Awesome. Miss Tanisha, what did the plate say to the fork?
You got me, Mr. David.
It said, "Lunch is on me."
That's a good one. Did you know that musicians use forks too?
Oh, really?
Yes, they do. But not just to eat their lunch.
So not this one?
Not that fork. This fork. This is actually called a tuning fork. It is an elastic metal used to allow the musicians to hear a perfect pitch of a particular note. So they'll use a mallet to
that's so cool.
tap on the tuning fork, and they hear that sound. Now what causes the sound is the vibrations through the fork, and we can see those vibrations just by touching it on the surface of some water. So I'm going to really get this tuning fork going by banging it several times.
Oh, I did see those vibrations.
Did you see those vibrations?
That's so cool.
That's the sound traveling out of the tuning fork into the water, just as they would travel out of the fork and into the air.
I see. Good demonstration, Miss Tanisha.
Is there any other way that we could see sound?
Yes, there is. We can make this rice dance. So what's happening is that
Whoa.
there's a speaker in here, and because of the vibrations of the music, we can see the rice move just from all the sound happening.
I can't wait.
All right. Let's get some music going.
I hope this rice dances right off the top.
That is so cool.
That is so cool. While we can't see sound, it's pretty cool knowing that it's traveling and vibrating all around us. Mr. David's going to show you an activity that you can do at home to see how sound changes as it travels through different types of materials.
For this at-home activity, you'll need 3 spoons, 3 paper cups, 2 feet of twine, maybe a small little thing to tie the twine to inside the cup, some plastic string, and some yarn. What you are going to do is you're going to tie a knot around your spoon. And then with your free end, you're going to feed your string, twine, or yarn inside the cup. Tie it to your little placeholder so that the string doesn't fall out. You can also use a knot inside the cup as well. And then once you have done that, you'll be able to have the cup up to your ear, and you can be able to hear the frequency and vibrations from when you take an object to strike the spoon. And then you'll hear all the sound vibrations moving through your different material, and you can hear all the different kinds of ways sound can sound.
Mr. David, now I have a riddle for you.
I love riddles. What is it?
What can fill a room but does not occupy any space?
I'm going to guess air.
No, remember those air molecules?
Oh,
bounce
you're right.
around all over the place. Actually, it's light.
Ooh.
Sunlight. Sunlight is filling up this space, but it's not taking up any space. So today we're going to look at how light also travels in waves. We can see light waves and rays by using this prism.
Ooh.
And breaking apart the white light and using this prism that's cut at a very precise angle to cast a rainbow of colors right onto the table. Now it is breaking up the different waves of light that travel to show all the different colors that are actually combined together to make white light. Pretty cool, huh?
That is really neat. I see all of the colors.
So we also have all the colors right here in felt. So remember the rainbow colors. Just remember my friend Roy.
Okay.
Say Roy.
Roy.
His middle initial is G.
G.
And his last name is Boov.
Boov.
Yeah, pretty funny, huh?
Yeah.
So R-O-Y.
Oh, I see now.
G. Boov.
Boov.
Roy G. Boov is my friend, and that helps me remember the order of the light spectrum colors. Each of these colors travels in a different wave pattern. The red wavelength has the biggest waves. It has the largest frequency. Sorry, the smallest frequency. Frequency is how many times a wave goes in a given space. So there are big waves, and you measure the wavelength from crest to crest. Crests are the top of the wavelength.
The tops, okay.
Or from trough to trough. What do you think the troughs are?
The bottom.
The bottom, exactly. So the wavelength is significantly bigger on the red compared to what it would look like if I made a wavelength in purple or violet. So those waves are really close together.
Whoa, they're so much closer than the red wavelengths
That's
are.
right. That has so much more energy in the violet. So if I were to keep going, you see there's a higher frequency or number of waves that would occur in the violet compared
To the red ones.
the red. Would you like to take a moment and help me put all the wavelengths on these colors?
Yes, I want to start with orange. This one seems to be almost as big as reds, but maybe not as large.
Okay. Thanks for helping me build out all the waves and the different colors of light, Mr. Davis.
Oh, it was my pleasure.
I heard you had a really cool way for us to capture the light spectrum at home.
Yes, we're going to make our very at-home spectroscope.
Ooh.
So, for this, you'll need a template that you can use and a either scissors or a sharp knife with a parent's help, so that you can put all the spaces into our paper towel tube that we'll be using. You'll also need a circle cut out of some paper to tape to the top with a small little slit inside it, and to blast from the past, a CD. So with our CD and our template, we'll put it at the bottom of our tube like so. We'll tape it there, and then we'll cut out where we need to cut out. And once we have done that, we have a slit where we can put our CD in.
So a frowny face and a rectangle for viewing. Okay.
And now we can put our CD in here, and our CD is actually going to do something very similar to what our prism did and allow us to see all the different wavelengths of white light.
Now, does it matter which way we insert our CD?
Yes, we want to have the shiny part that's reflecting upwards, so that when we put our spectroscope towards the sun and we look through our peephole, we can see the different wavelengths of light.
Pretty cool. Well, I hope that you have fun creating a spectroscope at home and investigating all the beautiful colors of light that you can catch in it. Next time you look up at a rainbow, remember the light spectrum. Today we explored how sound travels through different mediums, like solids, liquids, and gases. And we also investigated light and how it travels in different wavelengths, creating the color spectrum or light spectrum. Remember my friend Roy G. Booth to think of all of the colors in the rainbow. We hope that you have fun exploring and investigating light and sound at home. Remember to share your pictures and videos with us by emailing us at explorers@blueskyfund.org or posting them on social media with the hashtag ThinkOutsideWithBlueSky. Until next time, keep exploring, scientists.
Richmond is our home and we're ready to learn.